The sizes of atoms are related to the position of the outermost electrons, so the position of the valence electron. So, since the electrons exist in probability clouds that drop off in density rather than stopping outright, it's kind of hard to decide on what the position of that outermost electron actually is. And there are two common ways to describe sizes of atoms, and they are using non-bonding radii and bonding radii. The non-bonding radius represents the closest that two atoms of the same element can get before their electron clouds repel one another, and they bounce off kind of like billiard balls. The bonding radius is a little bit different. It represents half of the bond length between two atoms. So bonded atoms actually get closer together than non-bonded atoms can because their electron clouds are going to interact and they'll overlap slightly. And in general, most of the time people use the bonding radius when they're talking about sizes of atoms, and so that's what we'll be referring to from here on out. So there are two trends that we need to talk about when we're talking about the sizes of atoms, and those are the left to right trend across a single period and the top to bottom trend down a single group. For left to right, radius is going to decrease from left to right as the Z effective increases. So consider lithium and beryllium. Beryllium's valence electrons feel a larger effective nuclear charge, and that means that they're being more strongly attracted to the nucleus. And the stronger attraction actually means they're physically being pulled closer to the nucleus, and that causes the radius to decrease. The top to bottom within a single group trend is that the radius is going to increase from top to bottom because the valence electrons are going to exist in larger shells, so shells with a bigger N value. So we'll look at lithium and sodium. In lithium, the valence electron is in the N equals 2 shell, and in sodium, the valence electron is in the N equals 3 shell, and that N equals 3 shell is much larger and spreads out much further away from the nucleus, so sodium ends up being much larger than lithium.